Hello. I wanted to work through this problem with you, and I guess I chose this one because sometimes the idea of similarity is difficult for people to understand. So I wanted to show you one possible way to think about it. So let's begin by, oh, oops, sorry, I didn't open this yet. I guess what I wanted to talk about is the idea that similarity is very similar to proportionality, and you can think about this in a visual way, and I hope that this is helpful. So what we have here is that these triangles are similar, and that means that corresponding sides are proportional, and you're probably thinking, Dr. Fisher, too many words. Well, point taken. Let's draw some pictures. So this is, if we want, we can think of this as two different ways of measuring distance in a certain sense. So here's triangle QPR. And then let's say this represents distance in triangle ABC land. So 0 units of distance in this triangle correspond to 0 units of distance in this triangle. And so what this really means is that if you go 6 units on triangle ABC, that corresponds to some unknown number of units on triangle QPR. And that's true because this side corresponds to that side. What color do I have off now? Okay. So this side on triangle QPR corresponds to this side on triangle ABC. And so you're like, well, 6A, that doesn't help. True, okay, I can appreciate that. However, we also know that 10 units of distance on triangle ABC correspond to 15 units on triangle QPR. What that means is that if we take A, the distance A is the same length proportionally as 6, and so the distance from 0 to A, when you compare it, the distance from 0 to 6, that has to be the same magnitude as the distance 15 is from 10. So another way of saying this is that 15 is what 1.5 times as big as 10. A has to be 1.5 times as big as 6. And so it turns out to find this number, if you just multiply this by 6 and this by 6, that 6 divided by 6 is 1, so it turns out that A has to be 15 times 6 divided by 10. And so get out your calculator. 30, what is that, 90 over 10, I believe. I'll just check with a calculator that I don't have running right now. Okay, 15 times 6, I think is 90. And then, of course, divide by 10, we get 9. So A has to be 9. And notice that 9 divided by 6 is 1.5. 15 divided by 10 is 1.5. And that's another way to think about what it means for triangles to be similar. When you look at corresponding sides, they are the same in ratio. So the distance from 9 to 6 is 1.5 times. 9 is 1.5 times as big as 6. 15 is 1.5 times as big as 10. And fundamentally, that's what similarity is all about. So I hope this was helpful.